If I write it down, you write it down. I didn't have to use those numbers. I could have used anything that I wanted to. Do you see any degree measures on there? These are just names. That's angle 1, 2, 3, and 4. That's angle 5, 6, 7, and 8. Instead of using letters, which would require me to use 3 letters at a time, that can get bulky and inefficient. We're just using one number to represent the name of the angle. I call these groupings or systems of angles. You won't see those words necessarily in a textbook. That's my terminology. So 5, 6, 7, and 8 are also a grouping or a system. What do the groupings or systems add up to? Rachel? 360. So when we're completely done with some of these problems, a way to check yourself is to look at the groupings and see if they actually add up to 360 degrees. Let's label this interior. This is the exterior, and this is the exterior for this style of problem. And when I say this style of problem, I mean problems that typically are going to have parallel lines. So we're going to add arrows to all of these just to indicate that they're parallel. Let's label these 2 lines with some lowercase letters. Typically, we use lowercase letters to represent lines, especially when we have a few lines together. Let's label this one C. In addition to putting in arrows to indicate that things are parallel, I could also do this. Write down some vertical lines. All of those things indicate we've got a parallel situation. Anybody remember what this line is called? The one that touches the other lines? Transversal. How would you describe where angle 2 is in that system? If you had to describe how to get to it, what would you say? Where is it within that system? Up, down, left, right? Where is the 2? Upright. What's up and right in this system? 6. We don't say that angles are in the same position. We say that they are corresponding angles. They're in the same relative position within their system. So what corresponds to angle 1? Angle 5. What corresponds to 4? Angle 8. And angle 3 and angle 7 correspond. Same position, we just call it corresponding. When we have parallel lines, the relationship is that they're equal. If you see the term relationship come up on any worksheets, we're looking for something like either equal, complementary, supplementary, etc. In this case, the relationship is equal. We can come back to that if anybody needs it. Draw this shape on this one and this shape over here. How would you describe that pattern? What kind of letter does it look like? What kind of letter? Z shape. If you've got a Z shape or a backward Z shape, you are probably looking at an alternate interior situation. Let's put some degrees in this time. And let's put in some arrows. Thank you. We can use all of this terminology whether it's parallel or not. But it's more useful when things are parallel, so we're going to show parallel examples. What is the relationship when you have alternate interior angles? Are they equal, supplementary, complementary? What do you notice? Write down relationship. Equal again. Actually think about the words you're writing. Interior. We're talking about between the parallel lines. Alternates. We're talking about opposite sides of the transversal. One's on the left, one's on the right. Left, right. Left, right. Opposite sides of the transversal, interior to the parallel lines. Put that one away. Let's put some arrows in. We want this to be parallel also. And let's put 80 degrees up here, 80 degrees down here. Where would you describe, how would you describe the relationship and the positioning of those angles? First of all, what's the relationship? Equal, supplementary, complementary? Equal. Most of the things we're going to deal with in this chapter are going to be equal. Where are they? Are they interior or exterior? Exterior. Are they on the same side of the transversal or opposite sides of the transversal? Opposite. One's on the left, one's on the right. We don't use the term opposite, we use the term alternate. So we are looking at a pair of alternate exterior angles. When things are parallel, then the relationship is equal. When you are looking at complicated parallel line situations, don't forget what you've learned already. If I have angles that are equal in that position, what do we call that? What kind of angle pair? Vertical. Don't forget about your vertical angle pairs, which are also equal. When I look at a diagram, I immediately look for vertical angles to start off with. Let's make this parallel. If you know one angle within a parallel line transversal system, you know them all. Let's put 30 degrees right here. You got to start with something. Fill in the rest. Go ahead. I would start with vertical angles. Why can I then do this? How do I know that this grouping or angles within that grouping are the same as the angles in the other grouping? What do we call it when they're in the same position? What term did we use? Corresponding. So I corresponded. I got 30 and 30 and 30 and 30. What's got to be right next to 30? Right? 150. What's your justification for that? Supplementary, linear pair. And then I just throw in the rest of my angles. If you know one, you know them all. They all correspond. You still have vertical angles. You still have linear pairs. And what should each system of angles add up to? 360. It's a way to check yourself. Make sure lines add up to 180. Make sure that systems add up to 360. We'll be adding towards the backs of these later on. Here's your third sheet. Not have second periods. Second period got eaten by the PSAT test. Let's put in parallel lines. Things are more useful when we've got the parallel situation. And this time, let's put in this shape. And over here, we'll do it this way. Let's put in some numbers. We'll put 140, 40. Over here, let's put 70 and 110. That's 110. What's the relationship this time between the angles? They're not equal. What are they? supplementary. 180 degrees. This chapter is going to be very similar to our vertical angle linear pair chapter in that things are either going to be equal or they're going to add up to 180 degrees. What letter does this look like that I'm creating here? C. So we're looking for a C shape or a backwards C shape, however you want to think of it. And that's the first letter in the word consecutive. Put a big C there. Where are these angles? Interior or exterior?
Interior.
Interior. They're between the parallel lines. So we call these consecutive interior angles. Their relationship is always supplementary. Are they on the same side of the transversal or opposite? Same side. You might see this term. Same side interior angles. Both of these terms mean the same exact thing. Some textbooks use one, some use the other. The SOL test for Virginia uses both. So you just got to be ready for both terms. Don't forget everything you've learned up until this point. If I have something like this, what do we call this? Very good. Linear pair. What's the first part of the word linear? Line. I still have people writing down linear pair as a justification, but then they set up an equation where things are equal. This adds up to 180. A line is 180. One more time. Let's put in 50 degrees there. If you know one, you know the rest. Let's use consecutive angles or same side interior to finish this off. If that's 50, what's got to be right above that? Because of same side interior. Supplementary situation. You got to add up to 180. Then use everything you know about linear pairs. You know that 130's got to be here. You know that 50's got to be here. Use vertical angles. 130, 50. We know everything up here in this system has to be the same as this system if we have a parallel situation. So 130 and 130, 50 and 50, and all of those within the system have to add up to 360. Is this fairly easy? Yeah, but you got to know your terms. Corresponding, alternate interior, alternate exterior, consecutive interior, which sometimes is known as same side interior. Keep those in your notes. We will add examples to the backs of each of them.